Let's start recording. Sweet. Okay, so we have law of Demeter. Now, law of Demeter is one of those rules that's kind of I shouldn't swear, kind of bad. Sure. So the problem with it is that like it I kind of have this thing against like rules with exceptions. So if you have like a rule but it has like more exceptions than it has like cases, it's not a very good rule. And this is basically law of Damashar. It's almost everything's an exception. And so like it's not a bad one in the idea that the theory behind it is good. It's just like don't take law of Demeter as like the law of Demeter. Take it as like the guidance of Demeter. You know, it's like some kind of like indication, a hint, a smell of Demeter, right? So if you take it like absolute fact, you're going to find that your code gets like infinitely worse because like a little bit of like nesting, a little bit of like talking to friends is like actually good for code. Because one of the big things about code that you'll find is that it's so much nicer when it's easy to refactor. So when we write code that's what is it, like closed for modification, open for extension, one of the big things about that is that we also want it to be very, very flexible to refactoring. So we want it so that I can grab a bit of code that you wrote and just remove it and nothing else really breaks. Like things that kind of require it, sure, but like I should be able to go in and remove a standard satellite with very few lines of code, right? Like that's really important. And that means it's very easy to refactor that stuff, very easy to translate, very easy to kind of move and stuff like that. And that kind of plays into law of Demeter. So if you're kind of constantly talking all the way through the chain, for example, you grab a satellite and then you go inside the satellite, you look at all the files in that satellite, and then you look at all the stuff within those files, and then you look at like, maybe the length of that or something weird like that. And so you're going like 6 or 7 layers deep. That's insane. Like at that point, I can't go and remove like code relevant to that because your code somewhere else depends upon it. And that's really the concern. It's not really anything to do with really natural design. It's just about trying to make it so that code isn't coupled. But adding random getters and having it propagate all the way through all those random getters doesn't help anyone either. So there's kind of like it's this weird like balance between having like 1,000 getters in every single layer, just so you can go and like find the wheel texture and like actually not abusing this kind of I don't know, contract you have with the class. So if we look at UNSW training, that's not what I mean. One of the things we'll notice within this class is there's quite a few things. So the first thing that we'll notice is you have this kind of that's not what I want. I was like, this does not look right. You have like seminars. So for example, an online seminar, you have a normal seminar, which I can't click apparently, a normal seminar here. And you have some kind of trainer that teaches seminars, and then you have some sort of training system. And so when I look at this code here, can anyone tell me what they think is kind of wrong with this code? Very nested. So when you say nesting, is your issue due to the for loops? Is that what you're having issues with? So for example, if there weren't so many for loops, would you still be having an issue with it? So let's say the code looks something like this. Get seminars. Would you still have an issue if it looks something like this and presume the code's somewhat compiled? Beautiful. And I actually love Aaron's point here, which is that you can replace the getters with more specific methods. I'm a big fan of basically never having getters, except for things like very obvious, like kind of data related stuff. Because a lot of the time, getters are just like laziness. It's like, hey, I could have a function, or like setters are more important than getters in this case. But I could have a function, for example, to check whether or not this condition is true. But rather than having a function check whether or not this condition is true, I'm just going to do it manually. And so sometimes that can be promoted that, like, as an outside person, do I really need to know the attendees? And the answer may be legitimately no. Because maybe the only case you need the attendees is like as a list of strings, in which case you want like get attendees names. So you're making them more specific. And so what you're doing is you're saying, if I don't need this, I don't have it. Goodbye, right? Anyway, let's look at how we can kind of refactor this. So the first level of refactoring when you kind of approach something like this is to basically rip the band-aid off. My kind of habit for this stuff is to break code as fast as possible and just make the biggest changes you can first. So you kind of want to make the big structural changes, and then you want to make all the little changes, and then you want to test it, clean it up. Because otherwise you spend forever like changing code and moving stuff across and so on. Check. Okay, and so you're constantly going back and forth with these small changes, and it does take forever, right? And so one of the big things that I kind of, how I approach this sort of stuff is I go, okay, let's do the big change here, and the big change for me is this inner block here. So what I do is I look at this availability here, and I go, I kind of like this for loop. Because what this for loop is saying to me is this for loop is saying, here's all my availability. Let me check whether or not I can book for an available date. So what I would do is make the biggest sweeping change first, which is changing the structure of how this for loop works. Doesn't break anything, good. And then make the next biggest change, which is to basically go, this code shouldn't exist. I need to ask a trainer whether or not they can book for a seminar. But like, that's a weird relationship. Why does the trainer store the seminar? Like, that's the first thing I would realize. So I would immediately look at this and go, that makes no sense to me. I think the seminar should store what trainer is for that seminar. Because I'm not booking a specific trainer. I'm booking a specific seminar. In terms of kind of my relationship to the objects or to this kind of training system, I'm going to go to a specific seminar that's taught by a specific trainer, right? Rather than going, hey, do you have any seminars as a trainer that I can book at? Now it could be different. You could be looking a different way. And so I'll try to keep the structure here with the trainer the same, but I would probably make a change like that. That's like significantly structural and would probably break like a ton of code. But in this case, it's fine to kind of keep this relationship because maybe like it does kind of insinuate that like, but this is still just going to find the first trainer, then the first seminar. So like, it doesn't really make a lot of sense to me. Like if you're booking for a specific seminar trainer, I would expect the trainer to be passed. Anyway, enough about complaining about starter code. And so the next thing is looking at this kind of method here, whether or not I can book for this trainer. So I'm just going to make a statement, and I'm literally just going to say if trainer.trybook. I'm going to say, hey, I want you to try to book this appointment, and if so, return available. That's my beautiful code here, right? Book for this time, and if the booking is successful, add me as an employee, right? Which, I don't know. I don't like the word employee here either, because it's kind of weird to have like employees in that case. Anyway, so let's grab this code and move this inside a function inside trainer. So also, why does it exist? No need for that getter. Okay, so what we want is, I don't know, bool try book. Takes in a local date. I don't know if that's a time. No, it's just local date. Okay. For date, and then a string employee. Ugh, I still don't like the word employee. It's fine. Like, some people don't like naming this stuff like this, where you have this for date. The reason I typically name it is because in a lot of languages, what you can actually do is you can actually add a prefix here like this. You can't do this in Java. And so what that means is you can like have like prefixes for certain variables here that like are common. So I'd probably write it like this. So try to book for this employee for this date. Anyway, but you can't do that in Java, so we'll just kind of keep it somewhat sensible here. So then I just go through all my seminars, which is just going to be seminars. Words like seems wrong. Anyway, and then we check whether or not for date. Now I actually have a problem with this date thing as well, so we'll go through this in a second. But let's just keep this as possible, and if possible, we return true, else we return false. Okay. The next thing, sweeping changes. This shouldn't exist or either. And what you'll probably notice is what I was saying at the beginning, which is that trainers really don't have a relationship to seminars. Seminars have a relationship to trainers. And so you'll kind of notice that this function will look pretty empty in the end. And that's an indication of basically for date employee, indication of the fact that your object relationship is the wrong way around. Oh, I didn't mean to do that. Not true. Okay, seminar. Again, I have no need for either of those two dates, so just remove them. If I need to output them, I can add them as an output somewhere, but let's just not add stuff. We don't need to. You can add if you want. I'm not going to be too fast for things like that. Okay. And you also notice there's something here that happens that's quite nice. One, the code gets shorter. What a surprise. Like everything looks cleaner and so on. Okay, false. And the other thing is that this is actually quite nice in that we kind of get this less than 10 for free, and we're no longer like kind of just randomly adding this random invariant somewhere that, hey, this has to happen, right? We're actually adding it as part of the class. It becomes something that's kind of important to the class. So this is the thing that I always kind of repeat, which is like, you want to bring the context to where the class can be used outside. So you want to like generalize what operations you can perform on it, but you want to make the logic of how those operations specifically work in specific cases inside the class. So I should never really have to check if statements outside of class to see whether or not I can like run a function or something like that. That's like kind of not so nice. Anyway, so we have this beautiful try book function here that basically does nothing, right? And we'll probably rewrite this for streams in a second just to kind of show you how that works. I would probably make it a static variable, but it's fine to have it as a magic. It's like should be static, but I'm not going to take marks off. Like in your assignment, we'll probably point it out, but we're not going to take marks off if you do magics, because to me magics are just like it's not. I guess it's part of design, but I don't really feel like it's a significantly important part of design. Like it's good, you have to do it, but like I don't know, who cares? Anyway, so then we have the stripebook function, and this is basically what I'm saying. So this function doesn't do anything; it just kind of propagates this. And so to me, this indicates the fact the relationship's the wrong way around. So if the trainer has to go and all they're doing is asking the seminar whether or not they can book a room, what I should be doing is I should be asking all the seminars to book, and I should therefore, if I want to book for a certain trainer, go through the seminars, find all the seminars that have that trainer, and then book it that way, right? So it's kind of like the relationship is like lopsided. It's like, and this is a funny thing in that like pretty much this example has existed for like 3 years now. It was created in like 2018 by Robert. And pretty much it's been, I would probably say like it's even fixed like this is not good design because of this kind of lopsided relationship. Just makes it very clunky, right? Like if all I'm interested in doing is booking a seminar, that's all I should be doing, right? Anyway, so it's fine. That's it as is. And we can kind of look at that. Validates, we already talked about this, basically all this kind of stuff. I don't necessarily think this is true. I do say I don't like getters, but not for this reason. I don't like getters because I think it makes people lazy. But I think it's fine to use them, and like I use them all the time. Like I will have tons of getters in my reference implementations. It's just about control. It's just like saying, hey, Maybe at this point in time I'll add a getter, but before I commit it, I'll just look back later on and see whether or not I really need it right now, right? So you can kind of do a little bit of factoring before you commit. That's quite common. You kind of make a bunch of changes, see if they work. Once they work, you go back, you just kind of clean up a little bit. Online seminar, this is actually a really good point. So you can see this online seminar, and I'll put this side by side with the actual seminar. And let me just... there we go. So can anyone tell me what the difference or what the kind of a record what the violation of LSP or Livkov's substitution principle is here? So the key thing when you're looking at LSP is you want to look at the two classes and you go, okay, if I'm making any kind of presumption or if there's any kind of condition that's restricted on this class here, this class should have the exact same restriction. So for example, if you have a fruit class and the fruit class says every fruit is red, that's just what it is, that's the condition, is every fruit is red, that's it. And then you have an apple class, and the apple class says, oh, actually, you know what? Colors can be red or green. That is a breaking of Livkov's, because what you've done is you've taken a condition that used to always be true in the superclass, and you've now changed it to be partially true in the subclass. And the problem with that is it means that whenever you use that subclass as the superclass now no longer satisfies that condition. Yes, so you're inheriting this 10-person limit, but an online seminar doesn't have a 10-person limit. Also, you're inheriting this start time, even though the online seminar doesn't have a start time. So what's happening is you have something like an online seminar that isn't actually a seminar. And so typically there's two ways you can kind of solve this problem. And the first way is via something like composition. So what you could have is you could have something called a booking class. And a booking class would be like, oh, this generic kind of booking thing, like you could book a seminar or you could book like a training day, like a tutorial or a lab. And then you just have a generic seminar, which is just like, hey, this is just a thing. And maybe the seminar's online or maybe it's in person. And so if it's in person, it would have a booking. If it's online, it may also have a booking or of some different type, like some kind of some kind of record log. But doing it this way, you kind of inherit these preconditions, inherit these rules that say, hey, this has to have a maximum 10 and it has a specific start date when this doesn't have those requirements. So it means if I give you an online seminar for you to use as a seminar, it's no longer going to be correct. Even if I override this method and change this, your conditions of how you thought the class was going to work has been violated, or your presumptions. And that's basically the problem here. And effectively, this is what's going to cause the issue. Okay, so one of the things that we want to do here, just check something. Okay, so sorry. And so that's fine. We'll just keep going. So the next thing we want to look at is streams. Now, the thing about streams that I love is that they kind of really get a point here that you're trying to make, and they make it succinct. And so really what I'm trying to do, for example, this trainer function here, is I'm trying to find any seminar that can book. So what I'm actually going to write is I'm going to say return seminars dot stream dot hey, do any of these match this condition? Like tell me. Right? And so what I'm going to say is I'm going to say, okay, the condition that I'm trying to match is, hey, this seminar should be able to book for this date, for this employee. That's the condition I'm trying to reach. You can see I've just turned a very clunky kind of while loop, for loop, that had kind of this early exit. And I've turned that very clunky thing into something that's, I was going to say clean, but I don't really mean clean. Into something that's simplified. Okay. Yeah, it looks a whole lot nicer, doesn't it? Anyway, so that should be fine. Okay, so let's keep going. So the next kind of change. Oh, no, it'd be false. Yeah. The next change is work loves messaging me. Oh no, I did not do that. Yes, you did not do that. That's funny. People can't. Sometimes it's funny seeing like people try to follow instructions and they forget. Okay, I still this clunkiness here of this start equals. I kind of really hate this. I don't really want to rewrite it though because it's a bit clunky to rewrite. I'd probably like again restructure kind of how this works. It just is like very clunky. It's like whenever you have this like kind of like weird return true, return false. It's just I don't know. I'm a bit perfectionist about that kind of stuff. Anyway, so this kind of system here, how I would probably write this is something like this. So the first thing is I want to grab all the availabilities. And then I want to grab a stream of all the availabilities. Then I want to do, okay, now I've got all the availabilities. I now want to map all these availabilities to try to find the first value. So actually, I don't even want to map. I just want to like, really any. Yeah, see whether or not any availability matches. That makes sense to me. And then what I'm going to do is within this any match, I then have to go through all the trainers. So the easiest way to do that may actually be a zip stream. How do you do that? Is it like this? Let's see. I hate trying to get Java autocomplete. Let's see. I thought there was a way to do a zip stream. I may be wrong there. That's not the one I want. I could try to do it this way. Anyway, it's fun. How is zip stream? I mean, why don't we just Google it? Zip stream. That's not the one I want. Zip two different streams, maybe. The problem is that like zip is like, yeah, this is what I want. That's awful. Okay, so fine, you can't do it in Java. The joys. So I could do it this way, but I don't want to do it that way. Like, look at that. That doesn't look nice. I could do something called Guava, but that's a completely different library. But the whole idea of zipping is what you do is you take two different streams and you combine them into a single stream of two items like this. And it's just really nice. It's really convenient here. So what I could do is I could do a Cartesian product of all the availabilities with all the trainers, and then I could just say the first match between that Cartesian product. And it would make this a whole lot nicer. It would probably look something like stream, and then you would have like .zip with trainers, and then that would kind of zip them up so that you get one by one. I guess you'd probably want to actually say like Cartesian product or something, which is just gonna like do it so that every trainer gets bundled with every availability. So how a Cartesian product works is it's like a cross product. So if you have like A, B, C, and you're crossing that with 1, 2, 3, you're going to get A1, A2, A3, B1, B2, B3, and stuff like that. It's not really like a cross product, but it's kind of functional to how that kind of works. Anyway, we can just do this long way where you go match, and you go, hey, for each available date, like this. Let me just do a bit more logic. And my logic here is probably going to be just go through all the trainers. And then here we again can just track the trainer. Date, employee. There we go. Like, it's still cleaner, but like it's still not great. Oh, I don't want to do any. I want to do find first, I think. Okay, I can do a filter. Filter will work. The fun's of messing around with this stuff, but then find first. Then or else no. Done. Yeah, I could do the product in a lambda, but it would be still ugly, right? And I would also have to still like zip them together, so it'd have to have some kind of like tuple class, I feel, or like use like an array or something weird like that. This is probably just as clean. So what this does is this says, okay, and this is advanced lambdas, you guys don't really have to do this much, but I'm going to go through all my availabilities, and then I'm going to filter them. And what this filter does is it basically lazily filters. So this is the key thing about all of lambdas, is they're lazy. They only execute once you consume them. So for example, finding first is a consuming operator. They call them terminal. I'll probably call them consumers, and just like laziness, just because that's the terminology I know. But it really doesn't matter. Terminal is just like the final stopping point, right? And so what you're having here is you're saying, okay, this condition's only going to run once per item, but it's not going to go all the way through. It's just going to check the first item. And if it's true, then it's found the first item. It's going to stop. So this would only loop once. If it's not the first item, then it'll try the second item, and so on. And then if it gets all the way to the end, this returns an optional, which is like either a valid or not a value. And if the value does not have a value, we're saying or else. If it doesn't have a value, we're just going to map it to null. It doesn't run all the filtering first. This basically creates an iterator that will filter as it goes. You know what? I can actually show you how, some code of how this actually looks like. Someone liked my library. So I actually wrote a library for this kind of mechanic in a language called Zig. And the point of this language is kind of like a mixture of C and stuff like that. And it looks pretty much similar to what you guys have seen here, as you can see here. So I'm creating a range of numbers where this condition is true, and then I'm selecting some kind of, select is like map, and where is like filter. I just use where and select because that's kind of more colloquially known. Though Zig doesn't have inline functions yet, sadly. Maybe it does now. I haven't actually touched the language in a long time. But basically how it works, this is a different language, so it's confusing, but the point is that you kind of see where the where works, is that you can see that this is like an iterator. And so this is how the Java where will work too. And so what will happen is in your iterator, every time it gets the next item, it's going to go through all the inner items and until that returns the item that's true. So you can see that this stops as soon as the item is true, and then it returns the item. So it says this is the next item in the sequence that follows the value. So what this means is it's going to iterate all the way through until it finds the first value that matches the filter, and then it's going to return that. Then you call next again. It's going to go all the way through until it finds the next value that matches the filter. So it doesn't go all the way through. It goes all the way through till it finds a value that matches the filter. Maybe Java can show this as well. That would be nice if Java actually had. Can I? But the implementation would depend upon the implementation of the stream class. Maybe I can find it still though, because this is the interface. Here we go. This is honestly less readable than this, and this is a different freaking language, which is saying a lot. Like, what the heck is this? Something. Okay, well, we're just gonna skip past that. I presume it was. It's massively important that it doesn't. Because the thing about streams that make them absolutely beautiful is that they're lazy and fast, typically, because they're lazy. Otherwise, they just become really slow. But streams are typically slower than for loops, but they're still quite fast because they kind of have this lazy aspect to them. Anyway, so that's good. We've done that. Let's jump over to the fun of this stuff. Sure. I mean, this is harder than the actual example, but we'll go down to the simpler one and maybe that'll help kind of explain it to you all. So let's say, for example, you have this list of strings and you want to print them out. This for loop, sure, it works. It's fine. But let's say you want to feel extra fancy, you can just use a for each. I don't even have to use streams here. This is not even streams. This is just me calling the for each, and then it will just be me doing this print line. Now, there's a new mechanic here that we haven't seen before. I could also do a stream if I wanted to, just add like dot streams in front of it, right? Or dot stream. And the thing about this is that this double colon here. This looks very funky, right? And we saw it maybe early in the week or earlier in the month or whatever, when I kind of showed it off at one point. I kind of used the double colon to do some parsing. And I didn't really talk about it too much then because I was like, we'll see it later. And the kind of question here that I've realized is, what does this do? Does anyone know? So does this call the method? It's not similar to C++. I'll say Tom is correct, even though like it's not entirely correct. So actually, it may be correct. I don't actually know how it transforms the class code here. I can see. Why not? How do I open? Can I open integrated terminal? Javac. I crashed my job. I don't think that's a hard class. That's really funny. My God. Can I just run Java on it? I don't think I've ever. Yep, my Java's just not liking me today. That's really funny. Okay, I'm just gonna presume it's fine. Normally there's like a Java file that you can find. I'm sure I can like look at these logs, but like this is pretty much just big mood. Okay, fair enough. That's funny as hell. And then in this case it's static. I think you're correct that it probably creates a class and then probably just binds the class to call the println function, even though I wish you weren't. Because that's just like a terrible way of doing it, but I think Java does it that way. I know how this is transformed though. So this is the same thing as doing this. I'm gonna need type in C, please. I can guess it, I guess. Okay, so what does it require? Let's check. What does this for each loop require? Okay, apparently it's for each. It requires a consumer. Okay. Consumer of string. Hello. Thank you. And then I'm going to import it, please. The fun. Java.util dot function dot consumer, maybe. There you go. Yay. And then we have to implement this abstract method. Let's do that here. And then we have to just return, or just system.out string. So Java lies to you and tells you, send is real or whatever. And in this case, it's basically saying, oh yeah, lambdas are actually functions. Though they're not. They're actually just classes. So this is all it does. So in Java, this is what we call an anonymous class. And so what this is like a class that has no name. And so in this case, we're creating an anonymous class here that takes in some kind of function here that operates And then you're just basically, this is just an interface, and that's what this is here, right? This is just an interface that you're implementing for an anonymous class. So this is what this means. So if you actually look at it, this is an interface. And so what we're allowed to do is we're allowed to create a new class from that interface, kind of. It's really funky how it looks. And the result of that in the end is that you can kind of implement these overrides very easily. There's a few other things of how they work, but that's basically what it is. And so it's not really a lambda. It's more like just like an anonymous function or anonymous class. And so the difference is mainly down to the fact that of performance. So performance is a bit of a concern sometimes with stuff like this. It's not a concern that you're ever going to care about really, unless you're doing like very specific stuff or you're in a very hot loop. And the problem is a hot loop is something that you run multiple times, like really often, right? It's like the core of your application. So the things that happens here when I look at this for each loop is that this function here is what we call a virtual function. So a virtual function is what we were talking about before, right? Where you kind of have to like go and look up what override it is. You can't just immediately call the function. Even though this is really just a static function. This is really just like, I know exactly what function I'm calling. Like, there's no reason to have this indirection. I could just pass a function pointer and see. Like, it really doesn't have to be that complicated. Java kind of adds this level of complication due to this kind of extra class. And so what that means is that every time you kind of do any of this stuff, you're always doing virtual function calls. And that's kind of expensive. It's definitely a lot more expensive than just a normal function call. And that's kind of one of the big kind of downsides of implementing lambdas in this way. So there's other ways you can implement lambdas. C# does them as actual function pointers. For example, it calls them delegates, but they're the same thing. And even in C# you can actually even convert a normal dynamic function into a delegate. You can like make it an actual function pointer. You can do some really funky stuff with it. It's actually a really cool language. But in this case, it's kind of still has a lot of that, but it kind of is implemented very simply. And you kind of pay for the fact that it's kind of quite trivial. Anyway, it's pretty cool still. This is actually very useful. I wish more languages had this. This is just an amazing way of doing it, that you can kind of bind this function very easily like this. But it probably still, in my opinion, should just be this. Like, it's kind of crazy to me that I can't just write it this way. And the reason why you can't is because, again, like, it's not really a function pointer. It's actually just like a whole new class, right? So I have to do this to convert it to a whole new class. This one, it wants me to create a list of ints. Okay, sure. So we'll create ints. Let me not use var. You can use var in Java, but people don't like it for some reason, so we typically don't. I will use it a little bit in my code though. I quite like var, especially when you don't necessarily 100% know like the type structure. Like if it's a really complicated hash map or something, it's like convenient and nice. Like it was added for a reason, but you know, people have different opinions about that sort of stuff. So the next thing we want to do is we want to do a map. Now, this is another kind of mistake that Java takes when how it implements this kind of stuff is, if you're ever writing a language, you can learn a lot from Java, is that it kind of fails at what we call type parameterization. And the point of type parameterization is that you kind of have this standard type or standard class or whatever. And then you can kind of change it based upon some kind of type parameter. So for example, you say, hey, if it's an int, it has access to all these extra functions. If it's a double, it has access to all these extra functions, right? And in this case, it doesn't actually have that. And that's kind of interesting because what that means is that, for example, if you map it to a series of integers like this, and you use, you know, I'm going to use the parseInt function like this, then what will happen here when I actually count, when I try to do a sum, is I see there's no sum function. And so this is kind of an annoying attribute of how this works. And so if I want to write a sum function, I'm going to have to write it manually, right? I'll show you another way to do it. But I'll have to write with like a... Can I just literally call it sum, maybe? That's quite nice. And so in this case, I can reduce it to just a sum. And so this will do the same thing. I thought I would have to give it like a starting point. I guess it's just an implicit starting point to sum it. Oh, that's different because it's converting to a list of integers, so you can ignore that. But Oh, okay, fair enough. I guess it just like knows the starting point based upon like some kind of default value they can initialize. Or maybe it's just going to give it a null and then it'll just like break a bunch of code, which is potential. Oh, you know what? The starting point for this will just be the first value. That's probably how it works. I actually think it's just going to use the first value. Really? At least that makes sense to me. Sure, you can presume there's a value. That's actually also interesting how reduce has that. That's crazy to me how that does that. Let's just come out of this code. Please. Really? Okay. So this is the identity we're reducing to 0. And you can write it the same way like this, yes. Well, the same. Sure, that's fine. Okay. This is equivalent to found any. Yeah, okay, so it does just use the first value. Yeah, and that's why it returns an optional, because if it doesn't have anything in the stream, there's no default value, so this becomes a value. So you would say like all else 0, I guess. I kind of prefer writing it this way. I think that's much cleaner, but yeah, each reason. Anyway, so the other way you could do is you could do something called a map to ints. And this map to int returns a different kind of stream, and this different kind of stream has like a sum function. Which is a little crazy to me that that's how that works. But anyway, if we actually want to produce a list of ints, which is really what our goal here was, funnily enough. Integer. I also think the sum function, sum function just returns an int, which is kind of funny to me when I can sum multiple ints and they're going to add to a value that's larger than int, but sure, okay. Yeah, it's kind of interesting why it doesn't int there. I guess like you'd have to map it to a long if you really wanted to do you'd have to do like that. But then you'd have to like pass long, it'd be a whole nightmare. Anyway, it's fine. So we'll map these to ints, and then what we'll do is we'll collect them into a sequence of integers for this thing here. Int or int list. Sure. So the way collect works is that we give it a collector. Now there's stuff under collectors to do this for you, and the one that everyone basically you guys kind of have to remember is this collectors here. Interesting. That's very interesting. Very interesting. That you have to specify that the. Anyway, let's just do this. Wait, why is it complaining? I know I could do it the other way, but I'm just trying to see. Collector capture. Oh, I guess you would have to do it like that. Oh. Very interesting. So apparently map to int can't even be collected into a sequence of integers. I'm sure there's a way to do it, but it doesn't seem that easy. I'm not going to bother anymore. But anyway, you can just map it to ints and then just collect them into a list of integers. Again, like I'm sure that's just like probably even something I'm missing, but it could also just be due to the fact that like they have all these like specialized types, and so like you may even need to use like specialized methods to kind of get those types to what you want, which again is just really clunky, you know. Okay. Stonks. This is a real presentation I gave, though this was internal, which is why all the diagrams look terrible. Because internal ones don't have to look nice. And so this was a 2002 actual server that we have that was just really slow and just terrible, right? I'm not going to talk about ethics, because that's the completely different thing part of this course. But the big part that was like, well, you're looking at these changes and you're looking at people who wrote code in the past. Can you blame them? And basically, the answer is you can't. You should never blame anyone, especially in your team, for bad code. A lot of the time, it's due to time pressure or other things like that. And also, it's just not a good culture. You should be trying to teach them and help them grow rather than place blame. So it actually started probably about like 4 months ago, right? And I was sitting down and I messaged my boss and I was like, hey, why is this so slow? It doesn't really do anything, right? I was like, this thing is, it makes no sense to me with why it's so slow, right? And then, a couple of months later, I was like, it shouldn't do any of this, right? And that's a lot of the time is you have this like bloat of all this like stuff that it used to do, but no longer does anymore. Because again, this is from like 2004 or something, right? And the web server it uses is from 2002. And so what you're looking at is you're looking at something that's very old and that's been changed over time and has like almost 100,000, 150,000 lines of code just in that alone, and multiple hundreds of thousand lines of code everywhere else as well. And so what you're looking at is you're looking at a very old system that's kind of become fragmented and become very kind of legacy, right? It has that kind of energy to it. And so this is what we call technical debt. And so the big thing is that with technical debt is that no one wants to fix it because everyone's scared that they're going to break it. But it turns out that a ton of things just straight up did not work. And a lot of this is going to contain stuff that you guys won't understand, but I'm just going to kind of skip over and just try to keep the general kind of overview of the system and try not to go into too deep levels because I have like 5 minutes to do this, right? And this was like a 1 hour talk. And so the thing is, a lot of time things aren't actually fixed. So if you go to a company, especially a startup, you'll find that their code, people are scared to touch it, but you really shouldn't be. Be happy to break things, because when you break something, you understand why it was broken, and you understand how to fix it, and you understand why it was fixed in the first place, and you kind of come to this better conclusion about how the system works. And so you should never be scared about breaking things, because that's like the point, right? It's to understand how it works. And so I broke a lot of things when fixing it, and we had to spend months testing this, right? It was a very large testing effort, and we have a great QA team who spent countless hours with me fixing bugs and kind of looking into stuff like this. And so the answer is it's probably not working. And so what we did a bunch of profiling. This is the first thing you should do anytime you're doing refactoring. You want to like be very surgical. Now, the way I do any kind of profiling and stuff like this is kind of a bit, I don't want to call it cowboy, but it's a bit kind of just like blindfolded in some ways. What I do is I kind of have a think about it in my head, and I kind of like imagine what the code's kind of doing. And I kind of think about it and go, why is it slow? And I kind of imagine what the kind of code paths is taking, and I kind of just sit there for like 20 minutes thinking about it. And then in the end, I kind of have some good idea of where I think it will be slow. And then I look at those specific sections and I kind of really zone in and like look at exactly how long they take. You can run these big profiling tools that kind of tell you the same thing, but typically they've got a lot of noise to them and they're a big pain. We did those as well, and they typically just concluded what I was thinking anyway. Sometimes they showed some extra things, or sometimes they were wrong in some cases and stuff like that. And so the first thing that we do is we have this concept called data mapping. And what that is it's converting a string to a number. And so what that means is that we can store numbers in our databases, which are much quicker to do comparisons on, much quicker to look up, much quicker to do filters on, much quicker to do everything on, and it has smaller memory footprints, and then we can convert them from integers back into strings when we present them to the users. And so data mappings is really, really important, but actually just doing the mappings was taking 20% of the time if it was uncached, which is a ridiculously long time. And we're talking about something that's taking 5 or 6 seconds when it should be taking 1 to 2 seconds, right? Like it took 5 to 6 seconds to load some of our dashboards, which is insane, right? Now this thing called blob storage, this is just basically like file storage in the cloud. And it was taking about 10%, but that's reasonable because we're talking about hundreds of megabytes of data being transferred to the server so it can process it from this kind of cache. So 10% to me wasn't really that unreasonable. I did reduce it, but not significantly. And then this is where profiling comes in. So profiling lets you look at every single function and tells you the most expensive functions. So I look at resizing dictionaries. That seems like a really crazy thing. And dictionaries are like hash tables, right? So what you have is you have a hash table, like a map. And whenever you add to the hash table, it only has a certain amount of memory that it has, right? And you may remember this from 2521, but they may have not explained how like they typically resize. And so what you'll remember, hopefully, from 2521 is that you had like some kind of dynamic array, right? And this dynamic array growed at like a rate. So basically, every time it got full, it got like 2 times bigger. If you don't remember that, that's okay. That's just how it works. So, right? So it fills up. Once it gets full, it gets 2 times bigger, and so on. Now, a hash table is pretty similar. And so what happens is it uses an array underneath the hood. You know, it has that whole hash thing, right? And so you're basically having this kind of big section here. I think you're hashing into chunks of memory here. So for example, maybe like the hash of 5 is like 0, right? Or whatever. And then what you're doing is once that gets full, once that reaches what we call a low limit, which is typically like 75% full, it will resize it to be twice as big. Now, it was that resizing operation that was taking twice as long. Now, that's really surprising because it was 5% of the runtime. Now, 5% of 5 seconds is a pretty significant chunk of time, right? Like that's a pretty huge amount of time. I go down to less than 0% or like less than 1%, because all I did is I said, well, a lot of these times we actually know how big it's going to be. So I can just tell the hash table or dictionary how big I'm expecting it to be in the end. And once I tell it that, it will automatically resize. So this is kind of like the thing you're doing. So this stuff doesn't seem like it's design oriented until you start fixing things and you start realizing that a lot of these mistakes are due to bad design. Here's the first big point. We have this idea called an action. Now, action is something the user queries. For example, hey, I've got this kind of task that I've been assigned, you know, this bit of feedback from something that says, hey, I hated your service, and I want to action it so I can assign it to someone. So I can say, hey, you have to deal with this. Now, that system was doing a whole lot of craziness. It was an absolute mess. It was just doing like 10 things at once. It had no clue what it was doing. It was breaking law of Demeter. It was doing things left, right, center. It was a nightmare, right? And when I simplified it down and refactored it and removed a lot of the kind of bad design things that we teach you in the course, it suddenly got a whole lot faster. And why? Well, the main reason why was there was this concept of like, get me the history, right? And so to get the history, what it would do, geez, some days I can spell with the mouse, some days I can't. Get history. So when you wanted to get the history, which was very important when you wanted to perform an action, because now you wanted to add to the history, then get the updated history, then you send it across. One of the things it did is it would just get the full history from scratch. But it already knew the previous history and already knew the new action. So why not just create the new history? So that was like a first mistake. The second mistake was when it got this history, it needed to do something, which was it needed to map the users to the IDs. So in the history, it would have like a sequence of things like, for example, you know, this user ID, you know, 257 performed action X, or user ID 300 performed Y. And so you would have these sequence of these tasks that people did. And you needed to map the names or the initials or whatever you're doing to these numbers. Now that mapping, what it would do is it would get every single user in the database and then individually look through every single user one by one and check the ID matches, right? Which is just miraculous, right? And the big problem with this is the users didn't even sit in the same server. They sat in like our central auth server, which is like all of our authentication, which meant it was a web request to go tell that server to get all the users and send them back. And now that's a very expensive call, because if you have thousands of users on a single portal, because it's corporate, right? So you have, you know, multiple employees, and each kind of company gets their own portal. So, you know, employees are segregated to a specific portal. When you have something like that, what you end up with is you end up with this huge slowdown because it's actually quite expensive to get all that user information. Because a lot of the time you don't actually care about all the user information. You know, it tells me every claim that every user has. Do I care about the claims of the user? The answer is no. I only care about very specific details. And so one of the big changes was going, well, instead of making this web request directly in this bit of code, we already have a bit of code for the identity service. We already have a chunk of code that's like, hey, I manage everything related to identity. Why don't we just go and get the history from the identity? Or rather go get the user list from the identity, I should say. And then the user list can have a cache, which is just like a little bit of memory. And this cache can synchronize with the auth server. And so what you end up with is a way that means if I go and get my user list, it's instant because I've got the cache. I've already got the previous users. And every time I add a new user, I just flush the cache. Right? Quite simple. And the next thing was just removing dependencies. Going, hey, this module relies on this other module, but it really shouldn't. This is like a weird coupling. Let me remove this coupling. And then you find you remove that coupling, and because every module caches themselves, it means that once you remove that coupling, once a module becomes invalidated in its cache, it needs to be refreshed. You made some data changes or something. It doesn't suddenly refresh everything in the entire system because nothing is coupled anymore. Everything kind of has its own position and place kind of in the world. So what you do is you end up simplifying everything and you end up keeping your caches for longer. Things become faster because now when you invalidate X, you don't have to invalidate Y because they're no longer reliant on each other. Here's my favorite one. We had this like list of filters, and every time we loaded this list of filters, we would have to wait for all the filters to load before we even loaded data, which is just like bonkers insane. Like when I'm loading my data and all the list of filters that I can apply, it's the same thing. Why can't I load them concurrently? Why can't I load them at the exact same time? And the answer came down to the design of the code. The code was designed in such a weird kind of conflicted way that there was no way for the data call to occur before the filter because it had to wait until the filters were loaded so that it could get its kind of little bit of information that it needed to kind of send to the backend, even though it didn't actually like it could be reordered so that information could be clearer. So it's almost like you had this concept of a filter. You're here. And this concept of this filter, let me just do this. Oh, okay, I can't be, anyway, that's fine. We have this concept of this filter, and this stores like claims. So typically, for example, you have like a list of claims of like, hey, claims is a fancy way of saying like these are like filters based on your identity or who you are. So for example, if you're the CEO of the company, you can see everything. If you're the store manager, you can maybe just see stuff related to your store. So they're like filters or like conditions just related to your identity. That's a very common term that you may see a lot. I think the other one you may see quite a bit is like roles, which is not necessarily the same thing, but they're kind of related. Roles, like what can you do? Like what actions can you perform? And so you have these lists of these claims and these filters. And the point is that to load these kind of claims-based stuff, you had to wait for the filters to load first. Even though all it did was grab the claims and then put them into the filters, it's not who's to say they can't grab the claims, put it into the filters, and then also put it into the data. Which is basically what happened. And then now suddenly you're doing these operations. This takes typically about 2 seconds, but this will scale up massively for the amount of data. And so this is about 75%. That's interesting. 75% of this core here, typically. It's a bit faster. And so what that means is that you basically have a 75% speed upgrade, even though you've done nothing. I don't know why I did it that way. You have a 75% speed upgrade and you're basically really literally just paralyzed 2 things. And so it's like, okay. And that's a huge performance increase. And then there's a bunch of other things I did due to front-end stuff I'm not going to get into. I upgraded it to a new release of a new framework, and that was a huge amount of changes. You know, as I said, about 45,000 to 55,000 lines of code was removed. I deprecated like half the thing. I was like, this stuff we don't ever use anymore. Just remove it. Like, be happy with removing stuff. You got Git history if you ever need it. And this is just what I've been saying. Most JavaScript is unused. So we had a lot of JavaScript issues. You know, talking about some stuff in the past. I was told by so many people, oh, you won't be able to reduce it. You know, so many people have tried before. They're like, the old senior developer tried, he couldn't do it. And it's just like, and the problem was is that everyone looked at it from the point of view of, oh, I can't remove anything. I have to keep everything the same. I came from the point of view of, no, I'm going to remove everything. I'm going to make a break. And so what I said is, I said, okay, let me deprecate everything I can. And once you start doing that, you start to realize you can remove half the JavaScript because all that stuff is deprecated code. Sure, it needs to exist if you keep the deprecated stuff, but I'm going to remove the deprecated stuff. And you probably shouldn't do this, but the big motto of a lot of the stuff that I did was ask for forgiveness, not for permission. Basically, go and deprecate a bunch of stuff, then email your boss and go, by the way, it turns out I think we have to deprecate all this stuff because I can't do it. You know, we can't upgrade it. It's too much effort. And they're like, okay, sure, I guess, if there's no other way around it. It's a great way of doing it because in the end, you end up with a kind of good way of solving it. And so this was the initial results, which is, by the way, terrible. I mean, look at those numbers. It's high, everything's red, everything's a mess, right? And I'm not going to talk about anti-patterns or asynchronous stuff because that's way past this course. Oh, this is all about concurrency and locking and stuff like that, and talking about fixes and all that kind of stuff. Should you deprecate? All the stuff that is deprecated. Over abstraction is something that I do think is important here. But I don't really want to get into, so I'm just going to kind of overcover. Just talking about like how to abstract things. Okay, yeah, it's not going to caches. There's a bunch of stuff here that's like way past it. We're just going to keep going. By the way, this stuff is actually really cool in C#. You know, enums in like Java. In C# you can do this thing called attributes, which kind of exists in Java to some extent, and then you can like generate code based upon these. So this will generate like a bunch of code that will run automatically to classify this stuff. It's pretty nice. Anyway, and this was the final result, right? So 25 to 80 is a pretty significant change. You know, 0.7 seconds to just show the page, 2.3 seconds till you can start interacting with it, and 2.6 is just on the border of red. So it's a really good result in the end, and was a huge amount of work and just like absolutely exhausting. And yeah, basically it. Cache course announcing you faster, everything is faster. Yay, good to do that. And then there was a bunch of other stuff that in the end, and talking about this, you know, there's a huge amount of changes. And then I talked about, you know, different stuff like this. And a lot of the time you kind of come to these really nice conclusions in the end, and it's really cool. And I actually have some numbers in this other presentation that I'm going to give today. And the big numbers that you can see here is these deductions from 9 seconds to 4 seconds and from 3 seconds to 1.5. So pretty much everything's about, you know, 2 times faster, which is really nice. So that's basically it. Hopefully that was pretty interesting. And like, I don't really like to do this stuff. I basically have not done it before because I don't really like to make it seem like kind of any kind of bloating or whatever. Not bloating, gloating, bloating. That's funny. All right. But yeah, so I'm pretty happy with it. Very proud. It was a lot of effort, a lot of sleepless nights to get all that stuff done. And basically I got that just from starting an internship. And then it was just like a couple months later, it developed into like a junior, then a couple months later into mid-tier, then, you know, within the next year, senior. And so when you're kind of doing a lot of this stuff, you just want to, like, if you can get internship, just go for it, right? Like, I was like legitimately like, I don't know if I'm that good, I don't know if I'll be any useful. And then you kind of get started, and then you kind of get really interested by some things. And I'm actually a pretty bad programmer in the grand scheme of things. And really, like, I'm not that good at algorithms or anything like that. But a lot of kind of where I guess like the ability lies from is the fact that I'm very curious. So if I'm curious about something, I'll go and find out the answer. And that's probably one of the most important things you can have if you're going to do an internship, is you don't necessarily have to be the smartest person in the room. I definitely am not. But you just have to be the one who's going to find out the answer, or the one who's very dedicated or is kind of very interested in this kind of stuff. That's really, I think, what matters more. Anyway, okay, sweet. So, if there's any questions about that, feel free to ask. Else, I'm just going to move on to design by contract, and this will take a couple of minutes. Then we can move into the app. Okay, subject to my design by contract. Can anyone explain to me what design by contract is? Let's just start with that. And if whether or not you think you've used it in the past. Have you used it in any courses before? Have you used it in any, like anything whatsoever? Anyone know? So the thing about design by contract, right, is it's about defining some kind of rule set or some kind of contract that you're going to agree to when you're calling a function. And so what you're basically saying is you're saying, hey, here's this function I'm calling. And this function has a series of requirements that I have to pass to be able to call this function. And these requirements can be very complicated, they can be very simple, and they can include preconditions, postconditions, invariants. There's a whole complexity behind it. But at its core, it's just saying, what can you assume when you call this function? What can you presume? What can you kind of conclude? So, for example, you have a very simple function like, I don't know, square. And what this does is squares a number. It takes in some kind of integer z. It then maps it to some kind of integer z, but this time this integer is positive, and technically it can include 0. So I mean, I think the way people typically write it is 0 plus. I don't really remember. And so this is saying, hey, I'm mapping from some kind of integer to some kind of integer, right? Now, this is a precondition and a postcondition as well. Your types actually constrict what can be supplied to a function. So the precondition here is that this is any integer. And the postcondition here is that this is any positive integer. And so what we've looked at here is we've looked at this distinction. You have, hey, this can be anything in the world. This could be anything as long as it's greater than 0 or equal to 0. And so this is precondition, basically, and this is post. But we could add more restrictions. We could say, hey, actually, you know what? The input has to be negative. Right? And that's still fine. You could add even more conditions that aren't even related to the types necessarily themselves. You could have a function that says, hey, before you call me, you got to make sure this image actually exists. You got to make sure this file exists. Because if the file does not exist, then who knows what I'm going to do. Probably throw a file not found. But maybe that exception leaks something. Maybe it doesn't clean up properly. So it's saying to you, hey, I'm not going to handle the file not found. There's no file, that's on you. Right? You got to make sure the file exists. Right? That's not really good coding anyway, but that is like a valid precondition. Now, invariance is all about, hey, this thing has to be true the entire time. So invariance matter when we talk about concurrency. So concurrency is a very tricky topic because it's very complicated. Concurrency is not simple, but the thing about concurrency is all about trying to run multiple bits of code at the exact same time and trying to synchronize those together. Synchronization. Trying to say, okay, I'm trying to, for example, I have 100 numbers. And out of these 100 numbers, right, what I'm going to do is I'm going to add them all up. I'm going to sum them all. Now, if I'm going to sum all these integers, what do I need? Well, I need the ability to obviously add them one by one. But how slow is that going to be? Well, it's not going to be that slow. It's only 100 integers. But what if it's a billion integers? It kind of gets kind of slow. What if it's 100 billion? What if it's 1 trillion integers? It's now getting very slow. And what concurrency allows us to do is allows us to split that up. And so rather than maybe having adding one integer one at a time, you could split that up into 4 different quadrants. And now you could have 4 CPU cores running the exact same code at the exact same time. Or they could be at different points, but like the same program basically. Or they could all be summing up these integers, right? And once they sum up all these integers, you just add up 4 values at the very end. And so what you've done is you've cut your work from 100 at a time to 25 at a time, plus 4 at the end. So 29. So it's, 30% of the cost. And this makes a huge difference. Concurrency is like a very important thing in programming. We really sadly don't teach it that well at the uni in terms of that much depth. But luckily enough, it's actually something that you can learn yourself. And the thing about concurrency is that a lot of time it's better to keep things simple rather than overcomplicate them because it's already so complicated. And so people do all this fancy stuff and then they find there's bugs in that fancy stuff because it's very, very hard. And that's why I found a lot with the portal, for example. People would make these presumptions that weren't correct. They'd make these kind of design by contract decisions that were just wrong. And that's because concurrency kind of wrote all these special rules and so, in these cases, this variable is not necessarily going to be synchronized across threads. So you could see one different version of the variable in different threads and stuff like that. For example, one of my friends did a prime solver recently, and I was kind of helping him just as like a side thing because it was kind of fun on the weekend, trying to optimize it. And it was single threaded, and it was doing like, I don't know, a couple 100,000 per second. And then we multi-threaded it and we changed how it worked, and it did like, I think 1 trillion in like maybe 2 minutes. 1 trillion in 2 minutes is pretty insane. I mean, he had like 64 threads, so he had a very powerful computer. But still, the point came down to the fact that when you split up the work, the amount of work you do is significantly less. And the really cool thing about it was that he wanted to do it so it used almost no memory. So it could calculate 1 trillion prime numbers while using, I think it was like 100 megabytes of memory max, which is like nothing. It normally takes like gigabytes just to store that much. And the way it would work is it would kind of like only store absolutely everything it needs to. Which is kind of cool. All right. And so design by contract is really important because it allows us to write less code. It allows us to kind of make these conclusions. And for example, the blackout assignment, one of the big things about the design by contract is this send file function, right? The thing is the send file function kind of seems like it's a design by contract, but it actually really isn't because we're telling you exactly what to expect. Right? We're saying, hey, if the file fails, throw this exception. If this happens, throw this exception. We're telling you 100% exactly what to do in every scenario, right? And so that stuff isn't designed by contract because that's not a precondition. The precondition isn't just, hey, the devices have to... The device has to have not already have the file because that's one of the things we say is if it already has the file, throw this exception. That's not a precondition. That's part of the code. But there's a few things that are. For example, the devices are communicable, or devices and satellites are communicable, and that means they can communicate. That is a precondition that you can presume. There's tons of preconditions that you can presume in this assignment. You can presume that we won't delete satellites while they're transferring files. If we won't delete satellites while they're transferring files, can anyone tell me, is that a precondition, is that a postcondition, or is that an invariant? Because it's actually a very important one. Because if you're able to delete satellites or devices while transfer is going on, that could cause a huge amount of issues. This is pretty much finishing up now. Beautiful. It's an invariant. That's all it is. It's a thing that you can presume is always true. Now, which function is it an invariant on? Or is it an invariant on the class itself? Is there a difference between the two? In this case, it's going to be an invariant on the function, the simulate function. Because the simulate function says, hey, you can always presume this to be true. The class itself can delete devices. It just can't within the simulate function. So the invariant wraps around the simulate function. Now, in concurrency, invariants are extremely important due to something called mutual exclusion. This concept of locking, and we'll learn about that later. And locking says, hey, I have I have complete ownership of this variable for the entirety of my function. It's mutual exclusion, a mutex. No one else can access this. I have the lock. I have the key. I'm the one with access to this single item. That's an invariant. That's a very important invariant. And this, I think, I don't really need to go too much into depth with. Let's just kind of quickly talk about it in like 2 minutes. So I want us to talk about invariants here, preconditions and stuff like that. I mean, none of these really have preconditions, because all these are like well-defined. Like, that's just math. Obviously, like division by 0, but that's nan or infinity. Like, that's still well-defined. It's just like well-defined to be like not a number. But like, if you're presuming the arithmetic has to be defined and non-infinite and non-nan, then sure, you could add a precondition saying that b can't be 0. I mean, the same thing with tan, right? So tan pi on 2, which is 90 degrees, is not defined. And for those wondering why it's not defined, I feel like people always forget this, is tan is sine on cos. And so all you got to think about is, well, pi on 2 in terms of the unit circle, I don't know, I'm talking about this for sure. You have this kind of circle here, right? Pi on 2 is up here. That's 90 degrees. And so the way it works is obviously like this is cos is like horizontal, sine is like vertical. So at this point, cos is like right in the center. So cos is 0. So what happens is this becomes pi on 2 is equal to sine of pi on 2 divided by 0, right? Which is going to be undefined. Pretty fancy how that actually works, actually. Fair enough. Okay. Yeah, so sure, you could define things for this if you wanted to. I'm pretty sure tan will throw an exception, maybe. Let's see. If the argument is 0, that's fine. I mean, these are like preconditions, actually, to be fair. If the argument is 0, then the result is a 0 with the same sign as the argument. Because there's a difference between -0 and +0. Sad face. Okay, it's a native function, so I can't look at it. Okay, fair enough. So the thing about like this is I'm not necessarily sure whether or not there is an exception. I would presume it'd probably throw an exception if it got 0, but I think it's also probably fair to do nan. I mean, I'm sure you can find out pretty easily. I mean, we could find out in like 10 seconds. Let's just do this. Does not look like this. It looks like quite a large number. Am I going crazy? That should be fine. I guess that's just like fair enough. Does something. Maybe it's just like the precision is not there. Yeah, no, I mean, like, it's calculating pi correctly. It's calculating 0 correctly, +0, -0. Like, it's actually doing the signs perfectly correctly as well. So I presume it's like this number is huge, right? It's not infinity though. Like, that's nowhere near infinity. So I presume this is just maybe some precision thing. Maybe we can do like this to try to up the precision. Nah, I guess you can't. That's really interesting to me how it still supports that. I'm sure there's a reason. Why it's so weird. I mean, but it's not really infinite. Yeah, you're finding a value that's close. So that's really what I was just saying, is that like you're kind of losing that precision. But I still don't think that's a really valid answer because to me this number is nowhere near close enough to what I would expect the number to be. Like this number is like I could go quite a bit larger, right? Like you can really like 10e to the 10. Like I could easily probably go even larger, right? Like look how big this number is. And you're telling me that that number is close to infinity? No, I don't believe that. It must be something else is going on because that number is nowhere near close enough for me to think it's infinity. And double can also represent infinity. You are perfectly correct. So, but the argument they're making is that double can't perfectly represent pi on 2. And so the argument is that you have a tan curve that looks something like this, right? And then at this point, this asymptote lies upon the pi on 2 axes. And what they're saying is that you can't perfectly represent this line here. And so the point is somewhere here, right? But typically it can approximate pi on 2 to like probably like 14 decimal digits. And surely 14 decimal digits should be close enough to correctness. Like if I do 10, like see, this says undefined. Like this thing can handle it. So to me, that is not a valid answer. To me, it must be something with how it calculates it. I mean, again, I just picked the first link. I'm sure if I looked a bit further, it would tell me very close. I mean, even .NET is apparently wrong. Okay, so this is the number from the question. So if I enter this number and I go and ask, for example, Desmos what the tan of this number is, it's undefined. Because guess what? Like, its number is pretty large. Like, see how big this number is? And see how, like, small this number is? Like, I don't believe that for, like, a second. At all. Like, even if I do negative, like, that number's, it's tiny. Yeah, it's times 10 to 11, which is very different. Oh, look, .NET is actually quite a bit. I like .NET. That's 16. That's much more precise. Anyway, who cares? Yeah. I don't know. I don't believe this. Anyway, I'm not gonna really look into it because if I find out why, if I end up getting really interested in this, I'll let you know in like an email or something. But I'm sure there's like some reason to why. That's a really interesting thing. Anyway, if one you find out, I'd love to know as well. But I'm sure it must be something how the native function is written. It isn't written to kind of support that kind of thing for whatever reason. Okay, you can also throw an exception if you wanted to. But whatever. So I think in that case, I would probably say that this would probably like. I guess the problem also is like, how do you write a precondition for a double that's imprecise? Like, because the problem is if I give you pi on 2, already that's not precise. So for you, what's the difference between pi on 2 and what's the difference between that number there, right? Anyway, so who knows? It does increase. Wait, why is it decreasing? Yeah, because this number should wait, what? Oh, this is radians. I keep thinking it's in degrees. And also I'm going the wrong way. But if I go lower, so it's closer and closer to the number, you can see it kind of gets to this point and then just stops. Doesn't go any further than that. Because of the precision limit. So it must be something to do with the precision. I don't know. Right. Anyways, I'm not going to get bothered anymore with that. Otherwise, I'm just going to get distracted forever. Okay, let me end this here. And then